Hello everyone, I'm Charitos, and today I'm gonna go through research that I have done in my PhD the last couple of years. This research is a collaboration between City University, Kindred Group, and Playtech, and this is AI for anti-money laundering in online gambling. Okay, let's start by meeting the team. Firstly, this is me. I have dedicated my research the last 3 years basically in order to use machine learning in order to strengthen the procedures in online gambling for the detection of money laundering. And moving forward, we have my two supervisors. First, Dr. Artur Garces. He's the AI expert behind this project, and he guided the experimental process of this PhD. And also we have my industrial supervisor, Simon Dragicevic, CEO of BetBuddy, which is now part of Playtech, which was our gambling expert in this project. Okay, now let's move forward. And and today basically we're gonna go through a few of the experiments that we did during this research. I'm gonna give an overview of the challenges that exist in online gambling related to money laundering, and then I'm gonna show you our experiments, a few of the experiments that we did, starting with the supervised learning experiment, and then I'm gonna give you an overview of generative adversarial networks, a method that we extensively used in this research. And finally, I'm gonna show you basically what we are currently trying to do, building an anomaly detection framework for, let's say, spotting anomalies in players' behavior and how we could potentially relate this with money laundering. All right, so fraud in the UK is defined as an act of deception intended for personal gain or cost to a loss to another party. This is not just for UK, it's a general term that is applicable to different countries and different industries such as finance, insurance, or gambling. And with this research, basically, we are trying to strengthen the processes using machine learning in order to better detect fraud and more specifically money laundering in online gambling. And we believe the industry needs that since 2017, in UK gambling firms have paid over £40 million in fines and settlements, and all the major cases were involving failings in the detection of money laundering, which is an indication that the industry needs to strengthen their procedures in order to improve their identification of suspicious players which could potentially relate to money laundering. However, one of the main problems that when we try to tackle this issue is that fraudulent cases most of the time are much fewer from the original ones, and therefore the imbalanced class problem exists, which basically prohibits us to have robust models in order to let's say classify with higher accuracy those fraudulent cases. Okay, initially in this research, what we did, what we wanted to understand the money laundering problem, and for this reason, we performed a series of interviews with various industry stakeholders in order to get their insights and what they think we should do and how, in order to, let's say, try to tackle this problem. When we publish our findings in the form of a white paper, which is here, and you could find it online. And some of the main challenges, basically, that our stakeholders mentioned during these interviews is that, firstly, criminals are very sophisticated. So for many times, it's hard to detect them because they could learn, say, the rules behind a system, or that they are, let's say, they are registered, so they could find ways to stay under the radar. Also, another issue that the industry faced is the lack of data sharing between, let's say, the operators. Imagine, for example, a player has been flagged for something suspicious in one operator. However, the same player could have a different account in a different operator. Therefore, he could potentially change his behavior in order to stay undetected. And finally, the other problem that the industry face is that operators are not getting, let's say, limited feedback from the financial crime agencies when they submit those suspicious cases. So they don't know actually if the cases that they have submitted are actually related to money laundering, which at the end prohibits them to build, let's say, robust data sets, which could potentially use for money laundering detection. Now, according to these challenges and these problems, our research during this period has been focused into these areas over here. Firstly, as we mentioned, the imbalanced class problem that exists in general in fraud detection dataset. So initially, we tried to tackle that with different ways, and we spent a lot of time working with supervised learning and synthetic data generation. And secondly, even though with supervised learning we managed to achieve good results, however, using supervised learning, you are unable to spot any new trends and behaviors that could potentially related with the risk for money laundering. For this reason, we are working on a different unsupervised learning approach in order to spot anomalies in players' behavior. And now we're in the process, basically, to answer the question of how we could relate those anomalies with potential money laundering behavior. All right, so now I'm gonna go through some of the experiments that we did in this research, starting with our supervised learning approach. It's at the beginning we did a comparative study where we tried to compare different machine learning techniques and their application in our problem. The process started by the process that we follow. It's can be seen in this slide over here. Initially, we took the data that our industry partners provided us. We spent some time of building new features in order to encapsulate better the behaviors of a gambling player, and with this way try to predict better, let's say, if someone is at risk for money laundering or not. Then, after the feature engineering process, which was really important in general in our process over here, we use different oversampling techniques to balance our data. Since, as we mentioned, we are dealing with imbalanced data sets in this specific problem. And then we apply that, use that as input in order to train our machine learning models, which from where we got an output which will tell you, for example, what's the probability of someone is to be at risk, to have high risk, for example, for money laundering. And that's the thought process basically of our supervised learning approach. Now I'm gonna talk a bit about our results. So what we did, we compared the output from the machine learning models with the output of the rule-based system that our industry partner uses. And we show basically that using the machine learning techniques, we could potentially improve the true positive rate initially, and with all our machine learning approaches, compared to the rule-based system, which could be considered as the first level of monitoring in an anti-money laundering system. Then the best method in general that we found out with the highest, let's say, performance was the extreme gradient boosting method, which achieved the highest overall performance with the best F-measure score, which was around 88%. And with the F-measure score, you could think of it as by an indicator of both false positive and false negatives. It's like an average, for example, between the false positive and false negative cases. However, even if I think we got good results with the supervised learning approach, using discriminative models could potentially have a different problem, because we're just using certain features in order to predict the appropriate class. However, we are not understanding the underlying distribution. A solution to that could have been using generative models, which will allow us to better understand the distributions of our data. However, many generative models come with Gaussianity assumption. And therefore, we work a lot with the generative adversarial networks, which at the same time are both discriminative and generative models. And now I will give you an overview of what is a generative adversarial network and how we used it basically in our research. So this is a framework, an architecture basically of a standard generative adversarial network. You can see we have both we have two networks, a generator and discriminator. And the generator basically is trying to match a random noise into the real data distribution. And so it's trying to generate data that are as realistic as possible. And the discriminator tried to discriminate those data into real or fake. So it's called they're called adversarial because the generator and the discriminator basically are trained against each other, since the generator is trying to create as realistic data as possible in order to fool the discriminator, and discriminator is trying to be as good as possible at detecting the real and the fake data. So that's in general the idea of the generative adversarial networks. And they have proven to be very robust to overfitting and very good at capturing the distribution of the data. However, some problems could be created using generative adversarial networks, such as that sometimes they are really hard to train. There's no convergence point between the generator and the discriminator, which means, and therefore we are not achieving, let's say, a Nash equilibrium. And also the mode collapse scenario, which means the generator always maps the input into the different inputs that it receives into the same output point. So it doesn't generate new data, but always the same data point. So having that in mind, we proposed a new architecture based on generative adversarial networks, and we use that for the detection of fraud in online gambling, and it's called semi-supervised GAN for fraud detection. Our architecture here comes with two parts. First, now we don't train our network here with the original data, but with the latent representations that we are getting from a sparse autoencoder. So we are using the original data as input in the sparse autoencoder in order to project the data into higher dimension, and use the output from the coded part of the autoencoder in order to train our generative adversarial network. Now, again, we have the two networks, feed-forward networks of the generator and the discriminator. Now, the generator, it is trained with a feature matching loss in order to tackle the issue of unstable training that exists in GANs. And also, we are adding a pull-away term in order to tackle the mode collapse scenario problem, which is related to low entropy. And we also extend the idea of the discriminator. Now, instead of just having the output to be able to predict real or fake data, now our discriminator is able to predict the normal and fraud cases. And if you want, you could find more about this method in our paper that we published recently, and we presented at the IGCNN last summer. And here we are showing some of the results with our proposed method. And we can see overall that, and we compare our method with the machine learning methods that we used before, together with the oversampling techniques that we mentioned. And we are showing that we are managing to improve the overall performance by achieving higher F1 score and better accuracy. The improvement in the F1 score is not very big, you could say. However, in fraud detection problems, even 0.50%, it could be huge improvement, since this could be translated to, let's say, 3 cases will be less 3 false positive or false negatives. And it's really important in the fraud detection area. And overall, we could say that our system improves the overall identification rate in online gambling. Now we're going to talk about a bit basically what we are trying to do now. As we mentioned at the beginning of this presentation, that using, say, supervised learning techniques, we are able to predict new trends which could be potentially related to money laundering. For this reason, we are trying to build a framework which could be basically help us to detect those new behaviors. So we have developed an LSTM, which is corresponding to long short-term memory network-based approach for anomaly detection. In the table here, basically you can see the input in our LSTM network. The raw data of a specific player are divided into sequence of 5, where we use as input the behavior, which is actually the type of the action of a specific player, which could be a bet, a deposit, or a withdraw, the amount of the specific action, and the result, which is win or lose if it's a bet, or success or failure if it's a deposit or withdraw. And we use also the balance after the transaction. So we use this information in order to train our LSTM network, and which basically at the end we are trying to predict the player's next action, and which is, for example, if the player we are predicting it to be doing a new bet, or let's say a new deposit, and the amount of that bet or that deposit. And after that, we are using those predictions in order to and we are, let's say, compare them with the actual actions that are happening in order to see if we could spot any anomalies. And we try to use a couple of methods, such as threshold-based approach, or to use Gaussian mixture models. And here we can see, let's say, an overview of our framework that we are currently using. And we are showing you an example of the output of this framework over here. Basically, at the end of this framework, our system will detect, let's say, 4 anomalies. So for this player, the system predicted that this player had these 4 anomalies inside the testing set that we used. And we are describing an anomaly as to be possible, unlikely, highly likely, let's say how likely, for example, that specific point to be an anomaly. And also we are showing the impact that anomaly has. And we have 3 different levels, 0, 1, 2, and 3. We're just showing basically how fair there is the prediction with the actual output. So we are predicting the output of the action, and we compare it with the real value, and also the type of the action, and compare it with the real value. So for example, in this case, we predicted a bet, but it was actually a withdrawal. So using that, with collaboration with the compliance team of our industrial partners, we could try to give an explanation into those anomalies. For example, here, if you have, let's say, an anomaly for the transaction reference X, this anomaly could be described as a bet that is larger than usual. And we could see that these specific players didn't have any large wins recently. So it's a bit strange, for example, for this player to bet this large amount. So an implication could be that anomaly could indicate the risk for money laundering. So this is a general idea and what we are trying to achieve with this approach. However, we are in the process of evaluating, let's say, those anomalies. Yeah. All right. Let's sum up now. So what we did generally in our research, we performed a series of interviews with different industry stakeholders in order to understand the problem. We got their insights on how they think we should approach to tackle this issue and how this research should go. We tested different machine learning techniques and we investigated their ability in order to predict high-risk players for money laundering. We also proposed generative adversarial network architecture for detecting fraud in online gambling, but also could be used for the classification of imbalanced data. And finally, we are we have built, let's say, an anomaly detection framework for real-time monitoring of a player's behavior. And now we are in the process of trying to evaluate those anomalies and correlate them with potentially risk for money laundering. And thank you guys for listening to me. And now I will welcome any questions you may have.